Indeterminate tomatoes are genetically programmed with a single aggressive directive: grow upward, forever. They are climbing vines that will continually stretch towards the sun as long as they stay alive. If you leave them completely unsupported on the ground, they sprawl. The plant wastes its energy pushing leaves into the dirt, creating a tangled, damp mess that rots the fruit and invites disease. To fix that, most backyard gardeners use the standard wire tomato cage. It lifts the plant off the soil, but introduces a new problem: an artificial 4-foot ceiling. The vine quickly hits the top, folds over itself, and gets choked out in a dark, cramped canopy. Placing a static, rigid boundary around an organism meant to climb infinitely restricts its access to light and air. You get fewer tomatoes, and the plant stops thriving long before the season is actually over. Professional growers avoid cages entirely. They use an agricultural technique called the lower and lean method. Here, you can see vines growing straight up toward a high greenhouse ceiling, supported by individual strings rather than rigid metal. At the top of each string is a specialized tool called a tomahawk. It's an adapted masonry reel that hooks over an overhead wire, unspooling a long, high-strength twine all the way down to the soil. To secure the plant to this twine, growers use ventilated plastic clips. The clip bites onto the string via a small hinge, then gently closes around the stem. This holds the heavy clusters of fruit securely without strangling the vine as it thickens. This system requires active management. The grower continuously removes side shoots, a process called suckering. This channels all the water and nutrients into a single, highly efficient main stem, known as a cordon. When that main stem reaches the overhead wire, the grower unwinds more string from the tomahawk and slides it down the line. The plant is lowered and leaned diagonally, keeping the fruit reachable while giving the tip fresh room to climb. By swapping a rigid metal cage for an actively managed dynamic scaffold, growers remove the ceiling. They engineer an environment where the plant has an infinite vertical runway to produce. This physical limitation mirrors how we have structured human learning for over a century. The wire tomato cage and the standardized classroom share the same underlying logic. This is the factory model of education. It groups learners by age, places them in a tightly defined box, and feeds them a pre-packaged curriculum with a strict, predetermined ceiling. When you treat intelligence as a standardized output, you force students to hit the top of the curriculum and stop. Those who want to grow further fold over themselves, losing motivation, while the unique, specialized skills they could have developed are pruned away to fit the container. A system built for mass uniformity simply does not have the architecture to support exceptional, individualized mastery. It prioritizes order over yield. We can replace that rigid box with the cognitive equivalent of the trellis, the AI-augmented mentor model. In this model, artificial intelligence acts as the infinite string. As a learner's knowledge pushes upward, the AI dynamically scales, extending its support and generating new challenges specifically calibrated to that individual's progress. This replaces passive consumption of a static lesson plan with a continuous, adaptive framework designed for self-directed growth. To see the actual output of someone operating outside the factory model, we can look at the physical artifacts of a deeply self-directed learner. This collection is an eclectic mix of highly specific projects. We see wireless photography flash triggers next to handmade screen printing frames, a Game Boy Advance, and a carefully cataloged geological specimen box. These items document the creator following distinct threads of curiosity, from electronics to natural sciences. They acquired specialized tools for each topic, building a deep knowledge base across several different fields at once. When a human operates with an infinite vertical runway, their intellectual output naturally becomes massive, cross-disciplinary, and entirely unique to their interests. Building this kind of knowledge requires active management. We can see this exact dynamic play out when this same learner uses two different AI models to identify the specific greenhouse hardware from our earlier example. As we can read in this output, the first AI misidentifies the metal reel as ceramic kiln furniture and stops short of providing real manufacturers. Instead of accepting the hand-wavy guess, the user pushes back, demanding the specific data they actually asked for. They pivot to a second AI. This response correctly identifies the tomato trellis clip, explains the hinge mechanics, and lists exact suppliers. The user then takes this highly structured, accurate data and feeds it straight back into the first AI. In this final exchange, the user explicitly schools the failing model. They point out the difference between bloated uncertainty and a fully closed loop of useful information, forcing the AI to acknowledge the superior structure of its competitor's output. This deliberate correction is the definition of agency. The user is not passively accepting whatever the machine spits out. They are acting as a creator, actively pruning and directing their digital trellis to yield better results. The tools to escape the cage of standardized learning are now freely available to anyone. The true limitation is whether you are willing to step out of the box and build your own trellis.